the cos x dx. All this, you can put a line through it, and you're just gonna put a du. And what's gonna replace the sine of x? You know, well, the squared stay. Who cares about a squared stay? That's fine. We just can't have any x's stay. Or if this was in terms of theta, we can't have, we need everything in terms of u. Oh, you got it. 1 over u squared du. But Jess, this is what I saw. I gave this test to everyone in early May. Remember we lost a couple days with the snow and ice?
Mm-hmm.
You remember that? I gave this in early May. And a lot of students, yeah, they did okay with this. And then I saw this. Just a few students. Is that right?
No.
There's something about 1 over u squared that looks like this. And it's not, right? That's you only do this for 1 over u. So how do you treat these?
-2.
Bring it up top, u to the,
-2.
it is Sterling, it's this idea. You know, we're gonna get it like this. So we say, all right, that's the integral of u to the -2. Pump it up by 1. Just be careful on the number line. -2 plus 1, you're like, is that -3 or -1? -1. Plus c. So this will, hey Sterling, this will be similar to that other one.
Yeah.
I'll bring that below, I'll keep it negative. I'll bring that below and just keep it negative. It'll be -1 over u. And u is
Sin x.
sin x. And remember I talked about Bob?
Mm-hmm.
Who's Bob?
Back of book.
Why did back of book write like this?
Because negative cosecant.
Let me see it. Yeah, there you go. Back of book did that. Don't let it freak you out. You're okay. This is fine, right? You can do this if you want. All those trig identities, feel free to do that stuff. You get the power to use any trig identity. There's been times where I'm marking a test, and I'm about to put a X on something, and I go, whoa, wait. And I start looking, I'm like, oh my gosh, dude put a trig identity in there and got it all worked out and stuff, you know? Dude did it right. I think I'll show that to you, look. We did this last class, but last time we let u equal sin of x. Can we look at this 2 different ways? This is fun. Okay. U sub, which I let u equal to.
Cosine x.
So last class we let u equal sin x.
Mm-hmm.
It worked. Let u equal cosine x. No, the problem you did, Jess, if we let u equal to cosine, it wouldn't have worked. So you had to put it, what the key is, think about what's in the parentheses, or what's in the exponent, or what's under a radical. It's usually what you're letting u equal to. The derivative is, or be careful, positive or negative?
Negative sin x.
Negative sine of x. So I will do a step 3, because there's a negative. Step 1, step 2, step 3, negative du is equal to sine of x dx. Cool? Right.
Could you explain why you did the 3rd step for this again?
Oh, I do 3rd step. I do it most of the time. It's when a constant pops up over here. You know, other than just positive 1. I should be clear when I say that because 1 is a constant. There's always a coefficient of 1 of these. When it's anything other than just positive 1. So if you get right here for I, you get a 3, a 2, a 4, a 5, then take it and divide it on both sides of the equation. But this wasn't a positive 1, it was a negative 1. So I was like, all right, let me put it over here. Because look, this thing didn't have a negative in it, did it? So I'm thinking, this is what I'm trying to replace. That's how we gotta think. I'm trying to replace that, this didn't have a negative in it. Box that, go knock the sin x dx out. Box this, go knock out the cos. Let's see what we get. By negative q
du.
du. See? U is cos. Negative u is the sin x dx. Feel free, if you gotta use colored pencils, use them to just knock things out. Now, what's the integral of a negative u? So what do you get?
So negative cosine square x divided by 2 plus c.
Okay. Well, now this is what we did yesterday. Sine of x, cosine x. Stop there. For odd, look, no constant. I mean, it's a 1, but nothing other than a 1, right?
Mhm.
No negatives, no 2's. I'm gonna stop there. I could go in now on this one. This gets replaced with
U.
u. This part gets replaced with
du.
no negatives. I get just u squared over 2. So my answer now is sine squared x. So yeah, everyone, there are different antiderivatives possible. This is an answer or this. You go, how? Because of the plus c. That's why. But I want to make sure you understand why we can do this. Go ahead, Josephine.
Why is it negative cosine squared?
It was negative because that negative came up there.
No, but why is it cosine squared?
Oh, when we did the u squared over 2, we had to go back and replace that u. And then in this one over here, Josephine, this one we let u equal sine of x. So I had to put the u here as sine of x, Jess.
For the test, would you ask us to show like more than one antiderivative, or do we just have to know one?
No.
Okay.
But hey, you know what's neat? You just asked that. You know those AP exams? Well, you know, students get like 3, 4s, and 5s, all that stuff. They always put a killer problem there at the end. First, they make them really long. They go, here, you got 10 minutes to do this, right? You know, like 20 minutes. Who in here is taking the math AP exams? Aren't you crunched for time? I mean, you're flying and you're still like, oh, come on now. And they had one buried at like number 90. Just like that, all right? And it was this problem. That's why I'm doing it now. And they go, it was multiple choice.
Which one?
And they go, which one of these is possible? And then D was the what? All of the
Above.
above. Alright, now one of the choices was sine squared x over 2 plus c. It said which one of the following antiderivatives? Another one was negative cosine squared over 2 plus c. I'm not going to put the third choice up yet. But already, logically, what should be the answer to that problem?
A and B.
Whoever got to this, Jess, whoever got to this point, what would be the answer? It's got to be all of the above, right? Because we already know that these two what? Work that way. But it was the question, like, who got that far? Who got to number 90 to try that problem? So I want to show you the third way. You ready? Like, there's a third way to do this?
Okay.
And you go, what other way is it? Haven't we done both cases? So you go, all right, that's the beauty of mathematics. Who knows a trig identity? It's a
Two sines.
double angle identity.
Sine 2a.
It looks like this, but it has a 2 in front.
2 sine a cos a.
So I'm gonna go over here. And
Okay.
that's why knowing those trig identities are so important. There's a trig identity that says this. It's a double angle identity. Does anyone see that?
Mm-hmm.
So if, this would be a third way. So Josh, you'll like this. We just put, this would be way through. What was the original problem? Integral of sine of x, cosine of x, right? This would be a third way. Alright.
So sine
Can
2a.
I erase this?
Yes.
Sterling, okay if I erase all these?
Yeah.
Everyone okay? I'm gonna erase this stuff. The
So,
old school algebra, right?
oh, so
Back
sine
in the day.
sine 2x divided by 2.
You got it. So look at this trig item. Can I solve for sine x, cosine x over here?
Uh-huh.
Just divide the what?
By 2.
So look. This would be a third way to this problem. So Jess, to answer your question? No, I wouldn't do that. But they buried it at number 90 and they go, this was the question. So I can rewrite this as, what can I substitute in there? I can write it
Sine
as
2x.
1/2 of a sine 2x. But it still requires a u sub, so let's do it. This is good practice, Owen. If I do a u sub here, I gotta let u equal to what?
2x.
2x. What's d do?
X. 2, sorry, 2.
2dx?
Mm-hmm.
Step 3, I got a constant, I have to divide it. Step 1, step 2, step 3.
1
1/2 du equals
dx.
dx. There's already a half there, so what's a half times a half?
1/4.
Now be careful. That's 1/4. Integral sign, is it positive cos or negative cos?
Negative.
Yep, negative cos. So this was the other option. And then Jess, I'm gonna put the u back. Negative 1/4 cosine of,
2x.
that was this one. But Jess was like, who got that far, right? Now, if they knew just to try these two, I think logically they'd be like, well, if it's these are already, then this one has to be. Right? Because they're already confident that two of them. That, there's 3 different ways you can write that.
That's gonna take a lot of time.
I know. Yeah, and who has enough time to do that? It was buried way at the end. Not many get the number 90. When they go, you got 28 minutes to do these 30 multiple choice problems, take a break, come back, you gotta do numbers 70 to 90, and you get 28 more minutes, or 30 more minutes. You just crunch for time. Same thing with the SAT. Fine. Cool. Isn't that neat? But I guess, Jess, if I put that problem on my test, then I gotta put this on my answer key. Because students will write this 3 different ways, right? Yeah. Cool. All right. Everyone, I'm looking in the textbook and I see a good one. This is number 41. Good luck.
So that should be like 1/10.
Yeah, that thing. I am stumped. Josephine, I am stumped here. Where do I go? Oh, maybe it's one of these. No, it isn't.
It's 1/10.
Good, but then I'm still stuck.
So,
Think of that 5-star trig identity.
10 inverse x.
Cosine over sine. Tangent, sine over cosine, right?
Uh-huh.
That's how we get the integral of tangent. Let's make this what? Cosine x over?
Sin x. What if we do like 10 inverse x?
Yeah, we couldn't do it because cotangent. Inverse tan would be what?
Inverse cotangent. How to find the derivative? 3 integration, right?
Yeah.
Okay.
This will do it though. Now, hey, I'm gonna go to Jess on this. Do you know what I should let u equal to?
sorry,
So it can only be 1. Do you know which one?
sorry.
Yep, it's the denominator. Let u be the denominator, wherever the denominator is, because it'll knock out the top. It'll knock out the top. U equals the sine of x, you got it? So always think like that. Even if we did integral of tangent here, Josephine, we would have done the sine over cosine. Let u be the denominator, which would have been the cosine of x. Okay with that? Good. So I'm gonna let this happen. Boom, positive, right?
Mm-hmm.
Go in right now. Make the changes. Substitute. You're gone, you're du. You're gone, you're u. 1 over u du. What's the integral 1 over u?
Natural log.
Natural log of u,
Absolute value of sin x plus c.
which is natural log of sin x. I saw these so often in calculus 1, 2, 3. I just ended up memorizing cotangent, tangent. Can you go back to your notes? What was the answer to the natural log of it was a natural log. You remember
Secant.
integral cotangent?
Secant.
Yep, natural log of secant is what came out. Or negative natural log of cosine.
Uh-huh.
I just remember I was like, this comes up so often. Right? Hey, what will you see over and over and over and over and over again? Problems like this. And yes, it involves a u sub. What will you see over and over? Try it. What will you see over and over and over again? Problems like this. And yes, it involves a u sub. This is to your calc days.
But that one is like 1/6 e to the power 6x.
Yep. And so when you, if you can do these in your head, like you just did, by all means do it. If you're like, I can do all the steps. You're telling me this is gonna be 1/6 e to the 6x, we'll see, just put it, that's fine.
Can you do that on the test?
Yes. I'm serious. If you, look, you see this, you're like, I know what happens. I know, I get the steps. Let u equal 6x. Step 2, this 6. And then step 3, you divide the what?
1/6.
6. If you're one of these students, you're like, I see the math in my head. Integral v to u is e to u, and then you put your u back. The ration. By all means, boom. Right? I would be like, hey, where's the u sub and stuff? I know you could do all that in your head. That was good. You might be able to do that one in your head.
There's
Right?
no X, so wouldn't that just be the where is it?
Yeah, way to go, Messenger. Thanks for catching that. She's like, where's the x? Oh, that was just a constant, right? So wouldn't this just be, that would have been cosine 4 pi, you just put an x next to it, right? Does everyone agree? Look, what, like, what's the integral just 2? It's not 0.
X, 2x.
2x. So did you see my little typo? I didn't do it on purpose. I meant to put cosine of pi x. And I wrote cosine of what, pi 5? Or pi? Try this one. There's the variable.
Okay.
What would you let u equal to?
Pi x.
But see, this is another one. There's you in this class, you're like, I can do it in my head. It's awesome. You can notice a fraction comes out. du is pi dx. Farad constant came up, so I'm dividing it. 1 over pi du equals dx. Step 1, step 2, step 3, every time. Right? Boom, boom, boom. Every time you're doing a u sub. Come on in here.